Good afternoon to everyone present here. Welcome to our special FDS lecture. I would like to welcome our esteemed guest for today, Ms. Shivani Junawale, Professor Kapil Tejane sir, and Professor Rahul Pittare sir. Data structures are a key part of any computer algorithm as they allow programmers to do data management in an efficient way. The right selection of data structures can enhance the efficiency of a computer program or algorithm. To help us more to understand this, may I give a warm welcome to Ms. Shivani Junavane. She is the Senior Software Engineer in Persistent Systems and mostly works in DevOps. She is our alumni and has won many prestigious contests, including the Lady ADA National Level Programming Contest for Women hosted by ACM. She is also a contributor to various open source communities for supporting IBM Power Architecture. She will be delivering a talk on importance of data structures and data structure concepts, which is frequently used in the IT industry. I request you, ma'am, to please proceed.
Thank you, Soumya. I'll just start my presentation. Let me know if my screen is visible.
Visible, Shivani. Go ahead.
Thanks, sir. Okay, so I went through the SE syllabus that is there for the first semester for data structures course basically, and the references that I found were mostly for stacks and queues and arrays. So you do not have trees and some advanced data structures as of now. So I'll restrict my session today for stacks and queues itself. So moving on, I wanted to give an introduction about myself, but Soumya has already uh, said nice things about me. So what I'll do is I'll just quickly tell you what I've listed here as an interest in competitive programming. Uh, so you all must know what competitive programming actually is. It is basically solving problem statements on HackerRank, CodeChef, or any programming site that you find. So at least when I was in engineering, when I did my bachelor's, from second year itself, I started practicing on HackerRank and CodeChef and all of those platforms. And I was lucky enough to get an opportunity to participate in Lady ADA competition that is organized by ACM. And I got a chance to visit Chennai and Dehradun for attending the finals of this competition. And that is where basically the interest actually boosted. So I request you all to please participate in as many competitions as you can. And I don't mean I don't mean that you guys have to participate in competitions at such an higher level. But when you're starting from second year itself, try to participate in competitions which are held in your college department itself, maybe in IT department, maybe in computer department, or you can go to other colleges in that comes under the vicinity of Pune and participate in as many competitions as you can. That will basically give you an experience that will definitely boost your confidence, is what I like to say. And obviously, practicing on sites such as LeetCode, HackerRank, CodeChef is definitely something that I would highly, highly recommend you to do. It will not only boost your confidence in terms of competitive programming, but it will boost your confidence overall as a programmer. You'll get more confident as to you are able to solve problems, real world problems, using the programming knowledge that you have learned in your bachelor's or you will learn in due course. Okay, so moving on to today's session. So before I start, there is a very good quote by Linux Torvalds, and he says that there is a difference between what he considers as a good programmer and a bad programmer. A good programmer considers his data structure more important than the code that he writes. And if Linus Torvald is saying this, then it is definitely you can understand how important data structures can be in the real world when you go out in the industry and you try to create softwares and create applications. So one thing that you always need to consider is what data structure you are using for your applications. that is the importance that data structure has. So moving on to what data structure actually is, I won't be giving you any technical or bookish definition of data structure. What I'll do is I'll try to keep the explanation as practical as I can. And by that I mean data structure is nothing but a way of systematically storing your data. It is basically a way of structuring your data in such a way that helps your application to finally retrieve your data efficiently, maybe in big O of one time or big O of n time, as efficiently, as fast in terms of storage, in terms of time complexity, both. Let's just move on to the need of data structures. So here, as I said, I'll be giving you more practical examples as to why do we need data structure. So let us take an example of shopping app. It can be any shopping app. It can be Amazon, it can be Flipkart, it can be any shopping app that you use. But for this example, I have restricted it to Myntra. So by this example, you'll actually understand why and how data structure is actually needed in handling the complexity that your application has. So if you go to the categories tab of your Myntra application, you will see that there are 5 categories listed: women, men, kids, home, and gadgets. So just imagine the kind of data that this application has. It has literally thousands of clothing data, thousands of images, thousands of text. It has a lot of data, and it is not scattered. If it is scattered in variables, or if it is scattered in a way that is not efficiently retrievable, then the application will not have a good user experience, is what I'll say, and people will not want to open that application and actually use it. Suppose if I click on the women tab and it takes probably 2 minutes to load all the clothes that you see listed over there, people would not want to visit your app because that is not a good user experience, right? So you all know that a mobile application that is installed on your system is not able to store so much of data locally on your mobile. So this data is obviously stored somewhere on the cloud. So to give you an example, suppose the Myntra application has its database stored somewhere on the internet, and whenever you click on the Myntra app on your mobile, what it does is it sends an API post, GET request to the Myntra database, and receives some data from the database. That data may be the entire data or whatever you are requesting it at that point of time. But for simplicity, let's just assume that this database has a single table which has all rows regarding data related to all these 5 categories, and there is a column called as category, and which has one of these 5 values. Okay, so once we fetch that entire database, our application internally is running on your main memory, your RAM. So there should be an efficient way of storing this entire data over there that will help in efficient retrieval. So as I said, if you click on women tab, it shouldn't take 2 minutes or 3 minutes to process the entire table and then fetch out only the women entries. Or when I click on men tab, it shouldn't take probably 2-3 minutes to fetch that entire database. And every time you can't just loop through the entire database and create arrays according to what the user has selected. So there should be an efficient way to store this data structure or to store this data, and that is where data structure comes into picture. If you store the data in such a way that you can access any data that is present in this database in big O of one time, that is where you have achieved what the basic need for the data structure is. So this is a small code that I've written just to show you that one way of handling the Myntra database is to create multiple arrays and append the data to it. But this is a one-time thing. Suppose if I click on women, and then under women there are various other categories again. It can be tops, it can be shoes, it can be pants. Then how will you be creating more arrays for those categories? It doesn't make sense, right? You cannot keep on creating multiple arrays for storing all of this data. So you definitely need a data structure which can handle all of this data in an efficient way. I won't be getting into what Myntra uses and how it stores its data because I'm not sure about it, to be frank. But I just gave you this example to make you understand how important a data structure actually is in any application that you use, not just this Myntra application, but we'll see few applications ahead as well, where you'll get this understanding of how important a data structure is. Okay. So now that we know the importance of data structure, a couple of data structures that I wanted to quickly go through today are stacks and queues. And again, as I said, I do not want to give you any bookish definition. So I'll quickly move to another window over here. So I'm sure you already know what stack and queues are, and probably those are self-explanatory by the names that they have. Stacking is nothing but stacking something on top of one another, and queue is something that we stand in a queue or stand in a line, maybe outside a restaurant or a billing station somewhere, right? So a stack is nothing but first in, last out mechanism. So if I want to, you can imagine as a stack of books. So I'm keeping book number 1 in the stack. I'll be keeping book number 2 in the stack, and then I'll be keeping book number 3 in the stack. So whenever I want to access book number 1, I'll always need to remove the above 2 books, and only then I'll be able to access book number 1, right? So that is the simplest example that I can give you of a stack. And when it comes to queue, you can imagine queue as someone standing in a billing line, as I said, maybe a pizza delivery counter, I don't know, it can be any billing line. So suppose there is first person standing and there is second person standing. So you know that unless and until the first person's request has been handled by whoever is at the counter, the second person will not be able to order. It is as simple as that. And whenever the first person completes and comes out, only then the second person will be able to basically move on with the request. So this is some practical example that I gave. I won't be diving a lot deep into like what are the time complexities as to how do we access the elements and all of that. Whenever I give any session, one thing that I definitely like to do is code. I would not like to simply give you a theoretical session. So I have my VM up. So what I'll do is I'll click CD to desktop and okay. So let me just create a new file called as stack.cpp. Let us code. Let us see how can we actually code the stack example that we have seen as of now. So I'll be coding it in C++ language. So let's create a class stack and let's keep the data in the stack. Let's not redefine the size of the stack. We'll define it in the constructor itself. And then a stack will definitely have a top pointer, and which will be -1 at the start. Let's create some public functions. Let's first create a constructor, and the constructor will have size to be 1 parameter. And then So I'm creating an array of the size that has been specified by the user. So the user will explicitly specify the size of the stack that the user wants, and accordingly we'll allocate memory. We are not allocating any memory predefined to it. So what I'll do is so what a stack does, a stack needs basic functions are push and pop. Push is something when you insert inside a stack, and pop is something that you take out of the stack. And what we'll do is we'll write push function, and it will take some data that it wants to push to the stack. And then we'll write pop. A pop, in pop you can actually return an integer, but what I'll do is I'll just print the value inside the function itself. But the most important functions to write this push and pop functions are to check whether the stack is full or is empty. So I'll quickly write a couple of Boolean functions. Is full or is empty, right? And so let me code this. So when will a stack be full, right? If the top pointer in the stack is equal to size minus 1, right? That is when we know that uh, our stack is full. Else, what we'll do is we'll return false. As simple as that. For is empty, if we know that our top pointer is nothing but equal to minus 1, that is where our stack is empty, else we'll return false. So these two are very basic functions. We are just checking the terminating and the starting condition and returning true if that's true, else we are returning false. So whenever we do a push operation inside a stack, we definitely need to check if a stack is full. If the stack is full, then we'll not be able to enter. We are able to enter only if the stack is not full, right? So if the stack is not full, then what we can do is we can increment the top pointer and we can just add data to it. So this is right. Just insert that data, as simple as that. And if it is not, if it is full, then we'll just see out stack is full. And probably the same can be done in the pop function as well. But instead of is full, what we'll be checking is if the stack is empty. If the stack is empty, if the stack is not empty, then we'll decrement the top pointer and we'll just we'll first see out. We'll just first display whatever is at the top of the stack, and then we'll need to decrement the top pointer as well. Okay, I guess else what we'll do is stack is already empty. So actually coding a stack is as simple as this. This is the most basic stack that you have, and it needs just 4 functions. And inside, to be frank, you don't even need these functions is full as and is empty. I have just added it to make the code a bit modular. Sorry. So you can actually code this in the pop and push function itself. So that will actually reduce the size of the code a bit more. But as you can see, this is like the most simplest of data structure that you can find and the most easiest data structure to code. But there are few amazing examples of this data structure which you'll see ahead. But before that, let's just create a object of the stack, and we'll see if our code is actually working. Okay, so we have created a stack of size 2. Let's just push 1 in it. Let's just push 2 in it. And if I try to push 3, we should get a message that the stack is full, because we are trying to push a third element, and then we'll pop couple of elements, and then we'll try to pop another element, and the program should give an error that stack is basically empty already. So let me just move to my terminal. I messed up the spelling, I guess. This happens when you are coding a lot in Python. We have the binary. So yeah, so what we did over here is we first inserted, sorry, so we created a stack of size 2, we pushed 1, we pushed 2, and when we try to push 3, it should say that the stack is full, and then we are popping 2, then we are popping 1, and when we try to pop an element again, it is saying that the stack is empty. So the code is working fine. So before we move to Q, I will first like to give you example of this stack, a practical example of this stack of where it can actually be used. So let me move on to here again. Okay, so even if it is as simple code as you just saw, which can be maybe written in 5 minutes, but it has some really amazing applications. And the most important application of stack is nothing but an undo and redo stack. So I can actually open a Word document. Okay, so okay, what I'll do is I'm just writing Shivani. I'm just writing anything. I'll write PCC4E, right? And we have a very good functionality in this Word document, that, or probably any editing document that editing application that we use to basically undo what we have written. So if you see this icon over here, I can press this or either type Control Z, but I'll just press this, and you see the PCCO is gone, but you also get a redo typing option. So if I click on redo, I'll get PCCO again. Even if it is a very trivial application, but suppose think of someone who uses Word for writing a book. Suppose a writer who is using this Word document for writing his or her book, which is to be published maybe in the next month, and he has a hard deadline. And suppose if this undo redo option was not available in this Word document, I would have written an entire page, and by mistakenly if I did something and I deleted it, and there was no option of undoing what I've done, it would have been just a very bad user experience for anyone using the software, or no one would actually ever visit this, because they would rather prefer writing out their notes, writing out their notes on a paper with hand, because at least then they know that it won't get erased, right? So this is really a beautiful example of how a small data structure such as stack can actually add up to a user experience that makes a user use your application. And why is it called as a modified stack? So So before I move to that, let me just tell you how it works. So suppose you have typed command 1 and you have typed command 2, and then you type command 3 as well. But now when you press undo, what it does is it removes 3 and it inserts it into another stack. As simple as that. And when you again press the redo button, where you see, this is what I did. The command 3 I just removed from the stack and it has been inserted in the redo stack. And now when I press redo, what it does is it just takes whatever it is there in the stack, top of the redo stack, and inserts it back into the original document. It is as simple as that. But why is it called as a modified stack? So I'll first show it to you over here. So suppose I pressed undo and I removed PCCOE, and now I type something else as computer. So if you see, I don't have that redo option over here. I can never, even if I press undo, I'll actually remove everything. If I do press redo, I'll have computers, but the PCCO is gone. I don't have a track of what I've written. And why that happens is whenever you remove something from the undo stack and put it inside the redo stack, and then when you insert something new into the original stack, or probably you write a command after the undo operation, everything that is present in the redo stack is actually flushed out. So you won't have anything in the stack. So that is how the undo and redo operation works, and that is the reason why it is called. Uh, that is not probably a reason why it is called modified stack. There is one more thing. So suppose I write this command again, and then I write 5 and I insert it over here. Then I write 6 and I insert it over here. Okay. And now I want to write command 7, but there is no way for my application to track this command now because my stack is already full, right? So what this application does is it removes the bottommost element from the stack, and then it inserts 7. Basically, it shifts it all down and then inserts 7 from the top. And that is why it is called as modified stack, because in an original stack, you can only remove the topmost element. But in a modified stack, you can actually remove an element which is present at the bottom as well. And that just gives you a little bit more flexibility of the entire scenario that we want to accomplish in this Word document. So yeah, that is one example that I wanted to give about stack. Let us move to queues now. I've completed stacks. Let me just create a new document. Okay, so we know that in a queue, we'll need something to store the data as well, but we'll not predefine its size. We'll ask the user to whatever size the user wants. And then uh, in a queue, there are always 2 pointers. We just don't need the top pointer as in the stack. We need a front pointer. We also need a rear pointer in a queue. So we need 2 pointers front. Let's just assign it -1 for the start. Okay. So to efficiently use this queue or this entire array as a queue, what you need to do is you need to make this queue as a cyclic queue, and the is empty and is full functions for the queue will probably change. The formula for it will change, but for this session I'll restrict the queue I won't be creating a circular queue is what I meant. I'll restrict it to a simple array. So in the constructor of the queue, I'll have a size that the user will want to enter, and I'll assign memory data array of that size, and also have size copied into the variable. Okay, so similar to push and pop functions in the stack, in queue we have enqueue, which will actually insert some data, and we have dequeue, which will just remove the remove one element from the array, and we'll also need options to check is full and is empty. Right? So I think is empty would be very straightforward. That would be if front equal to -1 and rear equal to -1. Okay, fine. So if that is the case, I'll return true, else I'll return false. And to check if the queue is full, what we need to do is if rear is pointing to size -1. If the last, if the end pointer is nothing but pointing to the size of the array itself, then we'll return true. Else we'll return false. Okay. Now that we have our is full and is empty, we can just check as usual. If the queue is not full, then we need to check if the front pointer is not equal. If it is equal to -1, that means, or we can actually check if is empty. If the queue is empty, then what we need to do is we'll need to increment the front pointer as well as the rear pointer, make it both 0, and then add data to the rear pointer. But if the queue is not empty, that means front pointer and rear pointers are already pointing to some elements. What we'll do is we'll increment the rear pointer and not the front pointer, and insert data into the queue. So I guess this should suffice. Else we can just see out that the queue is full. When we are trying to dequeue or when we are trying to remove some element, what we need to check is if it is not empty. If the queue is not empty, only then we'll be able to remove something from the queue, right? So if it is not empty, and if rear equal to front, that means if there is only one element inside the queue, then we need to reset rear pointer to -1, and also front pointer to -1. But if that is not the case, we need the front element. So we'll just see out data of front and front plus plus. So we'll just increment the front pointer. I guess that should be it. Else we can just see out that the queue is empty. So obviously you can have a lot of modifications to this queue ahead, because what will happen in this queue is it is not the most efficient in terms of memory utilization. So suppose if I start inserting, I insert 1, I insert 2, 3, 4, 5, 6, whatever, and our is full condition is whether the rear is size -1. So suppose in this queue as of now, I have 4 over here, but there are no elements. That there is only this one element that is present at the last location of the array. So what will happen is this front pointer and rear pointer are actually pointing to the same location as of now. And even though if this 4 or 5 fields are empty and you can actually store something in this, the is full condition will still be met as per our current code, right? And because the is full condition is met, we'll not be able to insert new elements into our queue. But there is a way to resolve this by a mechanism called as circular queue. The only thing that you need to change is there is some formula that you need to do. You'll basically need to modulo the rear and front pointers with the size so that you get the actual offset value, and then use it in the is full and is empty examples. But for now, I guess this is good and a basic example. Let me create a queue of size again 2. I won't be creating a bigger queue, and just insert element 1 and insert element 2. Insert element 3, and then I'll for a couple of more times. So when I'm inserting 1, it should work. When I'm inserting 2, it should work. But when I'm inserting 3, it should say that the queue is already full, and then I should be able to dequeue for a couple of times. But the third time, it should say that the queue is empty. So just quickly see if our code is working. We have a queue.cpp. Let's just create an object, or basically a binary executable for the queue program. Okay. Did I mess something up? Where am I giving DQ? Achha, sorry. Okay. So Yes, this was the issue on my screen. Mm, okay, so I am able to create a queue binary executable binary. I'll just run it quickly. Yeah, so queue is full and queue is empty. So we got the output that we wished for. So when it will anyway, so let's just move to one of the basic example of queue that I wanted to show you in real life. So let's take a scenario wherein we have probably 4 employees working in an office environment wherein there's just one single printer, and all of them basically that job demands them to print maybe hundreds of documents every day. So what they'll do is they'll be sending continuous requests to this single printer that they have, right? And what this printer needs is it needs a mechanism to actually handle all these requests efficiently. So the printer is nothing but an embedded system. On top of that, an application is going to run, and the application needs an efficient way of handling the data that comes to it. The data is nothing but the documents that the user sends, but it needs an efficient way of scheduling that request in such a way that it handles requests in first come first serve basis, and that is where a queue is used. The application that is running on the printer will be using a queue data structure, and how it will be using that is, suppose employee 4 sends a request to the printer, it will the printer will automatically create a queue. It will insert employee 4's request inside that queue, and now suppose if employee 3 sends another request, it will add employee 3's request to the queue. If employee 2 sends a request, it will add employee 2's request to the queue, but it won't process those requests unless and until it is completed processing employee 4's request. So as soon as employee 4 completes processing, as soon as the printer completes processing all the documents that employee 4 has sent, it will take the next employee's request and process it. It is as simple as that. So whenever you send a request to the printer won't print the very next moment. It will wait. So suppose if there wasn't a mechanism called as queue in it, and the printer was just printing anything and everything that the user or the employee is sending to it. So suppose employee 2 document was already printing, and at the same time employee 3 also asked the printer to print. And if the printer did not have a coping mechanism such as a queue to handle those requests, what it would do is it might print documents alternately. So it would print one page from employee two's document, and it would print one page from employee three's document, and that is just a very bad user experience. No one will send documents to that printer to actually print if the printer is doing such a mess while printing the documents. So that is where even if it is a small data structure, even if those are very small data structures like stacks and queues, though these data structures are really, really, really important to actually have that user experience whenever your user is using your application. So when you come into the industry, any application that you make, you are obviously going to keep user experience in mind. Every minute detail, even if it is like clicking this eraser and trying to use it to erase something, uh, it is the user experience that matters. If the user is not able to erase something, the user won't be happy with your application, and then no one will be using your application. So user experience is like at the top of everything. And these data structures, if we use the right data structures underneath your application, it is an added advantage, I'll say, or not even an added advantage. It is the most important thing to do, to use the right data structure. Uh, there is one more example that I'd like to give. It is regarding a maze. So any uh, uh, I don't know. I can't think of an game application on Android Play Store or Apple Store that I can relate to this as of now. But suppose there was a game on the Android Store which was very maybe it was listed in the top trending games, and it was a maze game basically. So you had to so you had to find a path from this location to this location. And suppose you are playing that game and you arrive to this location, and then you, instead of coming down, you went right and then up, and then you encountered a dead end. So you'll definitely want to move back to the position that you were. You would want to move back to this position where you have two options. So this is another example where internally a stack can be used by the game to keep a track of all the moves, all the left, right, up, down moves that your application or the player is trying to play, so that he can anytime retrieve back to the. So if I move up, I know if up is inserted in the stack, whenever I need to remove something from the stack, I know I'll need to perform an opposite operation. So if I'm moving up, I need to move down. So that is how a stack can be used in this maze application as well. Obviously, that the points that you need to store in the stack are the points wherein you have options. So even if you come to this block, you know there are four. We have come from here, so we know that there are three options of going. We can go left, we can go right, or we can go down. So you will need stacks to basically store this information to efficiently later come back to a point that will help the player to move ahead in the game. So I guess, yeah, I don't think I have any more example. Let me go back to the code. I had applications, and I guess, yeah, that's it. If you guys have any questions, you can answer me. I guess we have time. If anybody has any questions, you can ask me, not just related to this data structure, but anything that you want to in general.
Students, you can post your question in chat box if you have any question regarding data structure, or if you want to ask anything regarding industry or something, whatever you want to ask. You just post your questions in chat box.
So it can be anything regarding maybe competitive programming or what sort of projects you need to make a good profile. Not just related to data structure, but if you have anything in mind, it can be a very trivial employee. So I have a question: what actually a company wants from their employee? Uh, so let me give you an example of what my manager would basically. So it is probably a year back. My manager was trying to recruit somebody for my project, and she was taking an interview. She discussed it with me after she came back, and that person, I guess, had around 5-6 years of experience working in some other company. But even then, the basic questions that she asked that particular interviewee was on data structures. So not data structures as such, but logical questions, like you have given an array and you want to sort it. So how will you sort it? What is the most efficient way of sorting? at least on the initial stage when you are joining as a fresher, the most and the important thing that you need to learn are your data structures and your basic algorithms such as searching and sorting. So your company wants you to understand what the basics are, and your basics should be clear. You can learn on new technologies. Whenever you will come into the corporate world, you will be working on tools and technologies other than what you have learned in your curriculum. But the basics, if you don't know how to use a data structure, or if you don't know the operating system concepts or the Linux concepts, because when you come into the industry, you will be working on Linux, is what I'll tell you. So make sure the subjects that you learn in your curriculum, those are the basics of whatever you're going to do ahead in your life. So make sure you are very thorough with that. But to give you just a pointers, data structure is one thing that the company will definitely want you to know. And some database related concepts such as SQL or no SQL. Janvi, is SQLite as an RDBMS prevalent in today's workforce? Yes, I would say definitely. So one of my teammates recently made a small tool. So we had a big Excel sheet and we were kind of inserting all the open source packages that we have ported into that single Excel sheet. But as the kind of rows started to increase, it was difficult for us to maintain that single sheet wherein there were probably 15-20 people trying to edit that sheet at the same time. So there was this team member who created a small tool that the entire team is using as of now to insert documents inside that sheet. It created a basic UI wherein we can insert and backend may he'll handle all the simultaneous requests and stuff like that. But the database that he used in the backend is SQL database. So it is not a NoSQL database, it was an SQL database because the data that we wanted to store was in a structured format. So yes, it is relevant. What kind of projects would uplift our CV the most, and which coding contest would we take part in to get most out of them? Okay, so projects, I would say you have your subjects like data structures. Make sure you do at least a single mini project on your data structure, be it as simple as coding a library management system, wherein you have actually stored that information in a file somewhere, obviously. But then when you retrieve that information or into your application, you have stored it in some efficient database, some efficient data structure, so that it is such as hash map or something, so that it is very easy to retrieve. And when it comes to OS as well, operating system as well, just make sure, be it networking, be it any other application, be it any other course, make sure you have done some sort of mini projects onto it. You do not always need to make a project that is very high end. Even if those are small projects, like maybe using Twitter API to gather some information and analyze some trends onto it. It can be very simple projects that you can actually make in a weekend or a couple of weekends or maybe a month. Make sure you do that. That will definitely help. And regarding coding contests, so when I started, because you guys are in second year, as I told, make sure you create your account on HackerRank, CodeChef, and all of those coding sites like LeetCode, and start by actually implementing and coding those problem statements first. And when you get a hang of it, like when you there are competitions that there are weekend competitions or competitions that happen on both HackerRank as well as CodeChef. So for the start, try participating in those competitions. Once you get that confidence that I'm able to solve these problem statements, then you can move on to competitions such as ICPC. You can there is TCS Code Beta. There are many other competitions for girls. There is ACM Lady Ada competition. So as you go ahead in your second semester, in your third year, I'm sure Pitai sir and Kapil sir, they'll share across details of various competitions that occur on a large scale, maybe on an India level, or CCS Sport Vita is worldwide, ICPC is worldwide. So make sure you participate in those competitions. Even if it is not important that you go and secure first rank, but just participating in that contest will definitely give you a lot of boost in your confidence as to you are able to solve something. I hope I have answered your questions. Is there any more question? Mridul is asking what is the main language that my company uses. So, Mridul, there is nothing like a company uses a single programming language. If you have that mindset that you will just learn C++ and you will have your entire career based on it, that is not true. In today's world, you need to keep on learning. You keep on, adding to your knowledge. So, typically, what happens is when you're working in a single project, that project may last for 2 years, 3 years, 6 months, or maybe 10 years. So you don't know how long that project is going to last. As long as you're in that project, you might need to work on a single language and probably couple of technologies or 3 technologies at max. But as soon as that project terminates and now you have to interview for another project in the same company, you can't be sure that you will have just that one single language or that one single technology in your resume and expect to have a project in that technology. You need to know couple of languages. You need to know couple of technologies. So don't just restrict yourself to a single language. And obviously, a company never uses a single language. So in my company, there are like projects in Java that requires Java, that requires Python, that requires C++, that requires Go for now. You must have heard of a Go language. So Go is something that is currently trending. I'm talking about my project itself. So we don't have a single language that we work. So I could be working in Python today, and next week I could be working in Java because we work on open source software. So we need to learn the language that the software is using, and then try to build that software and resolve issues and stuff like that. So there is no such one language that any company uses. You need to keep on learning when you are at the job. Yeah, I hope I have answered that as well. Are there any more questions?
Soumya, I think you can conclude the session.
Thank you, ma'am, for delivering such an interesting session and helping us understand data structures and their applications. You coding with us really helped us understand the concepts as well as their implementation. I would like to thank our HOD, Dr. K. Rajeswari ma'am, for constantly guiding and supporting us. I would also like to thank Professor Kapil Tazani sir and Professor Rahul Pitay sir for arranging the session and giving us an opportunity to further our knowledge. Lastly, I would like to thank our audience, the SA students, for being here today. Thank you all. Have a nice day.
Thanks, Soumya. It was nice interacting with you guys as well.
Thank you,
And
Shivani.
thank you, Kapil sir, as well.
Yeah, thank you, Shivani, for such a wonderful session.
Yeah. Thanks, Rahul sir.
Thank you. Thank you.